You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Podcast. I'm your co-host, Dan Blewett. On today's show, we've got a good docket of topics. Number one, we're going to talk about the EcoPulse hybrid designs, an interesting new aircraft, and we'll talk about some of that. NASA's Supersonic X59 has a wing milestone, so some good work from NASA, and we'll chat a little about that. And then obviously Virgin Galactic, still big and has its hands in lots of different industries, but we're going to chat a little bit about their space tourism plane. They had a concerning but still safe sort of abort as part of one of the recent test flights. In our engineering segment, we're going to talk about the Boeing 787 continuing to have fuselage issues. Some new slight defects have been detected, and we're going to chat a little bit about the way carbon fiber and other materials are machined and manufactured, and how difficult it is to get some of these really high tolerance parts built right. And then lastly, we're going to chat about Blade, which is a helicopter rental service, and their potential entrance into the EVTOL market. So, Alan, how are things going? We're closing on the holidays.
Yeah, it's going to snow. First big real snowstorm of the season is happening now, which means all our aerospace engineering companies in the Northeast are preparing for the worst, but that's okay. You know, it's part of the seasonal shift, and we're getting close to the holidays, Christmas and New Year and Hanukkah, and everything's starting. So that's exciting.
Yeah, it's been currently snowing and kind of half raining most of the day today. So it's definitely feeling Christmassy, that's for sure. So jumping into it today, what is striking to you about this EcoPulse distributed propulsion hybrid aircraft? It's coming out of France. This is news from Toulouse. But tell us a little bit about what this propulsion system is, and what do you think the long-term ramifications are here?
Well, it's being funded by the French government, and it is essentially a consortium of French companies like Saffron that makes electric motors. And it'd be very similar to what happens in the United States when there's government funding for a project where you're trying to boost the industry and get to the next steps. So the airplane itself, I don't know if the airplane's all that important. Maybe it is in a longer scheme of things, as much as developing the system components and the products that they can offer worldwide, in which they are totally going to do. So think of it as a government-funded jobs program a little bit, but also a technology development program that gives those companies resources. So the company names, it was Daher, Saffron, and Airbus. It tied in with, what was it, CORAC, the Civil Aviation Research Council in France, to tie them all together and see what they can come up with an aircraft. It'll be a demonstrator, more than likely, just to get something out there. But I know if I'm working on a lot of different aircraft programs concurrently right now, and you hear those names pop up more frequently in the last 6 months for electric propulsion systems. So you know that funding that the government of France is actually going somewhere. You can actually see it in exports, which is what they want. So airplane technology-wise, probably not so important in terms of setting new frontiers in an aircraft. I think it's more important in terms of just all the technology that's inside of that aircraft that France will now offer. And if Airbus and France want to be a hub of aviation, which they clearly are, then technology projects like this do have a pay period at them, and they will make their money back eventually.
Yeah, so they said Saffron recently finalized their technical configuration of 6 electric thrusters and will be fitted with 50 kilowatt engine US electric motors. So, I mean, Are the motors, like these electric motors that they're using today, are these going to be the ones that make it to market in a couple of years? I feel like electric tech is changing so fast. Is this?
Well, the Saffron motors we're using right now on a couple of projects in the United States. So yeah, it will be used. And all this, and I've had a couple of discussions with Saffron on some electric motor proposals that they're making, and the technology is amazing. It's nothing but amazing. The amount of torque and horsepower they can jam into a motor electric motor is surprising. It's really surprising. So yeah. it's going to pay dividends, no doubt.
So moving on, NASA's Supersonic X59, the assembly team is plugging along, and they've, I guess, gotten to a pretty big milestone in wing design and assembly. So tell us a little bit about the X59. What do you see from that project?
Well, the X59 is the supersonic development aircraft, I'll call it, that is going to be testing new approaches to reducing the sonic boom that you would normally hear on a fighter jet. And a lot of the sonic boom noise has to do with the aircraft shape, not so much that it's going so fast. I mean, the aircraft obviously has to go fast to get past the sound barrier, but the boom that happens is basically a collapsing of the air around the different surfaces of the aircraft. So if you can shape the aircraft so it's not so much of a collapse of the air as it is a gradual closing of the air, then you can decrease that sonic boom, because the limitations that are placed on aircraft today, particularly in the United States, because that market I know better, is you can't create a sonic boom over land unless there's in certain designated areas for the military. So, but essentially, if you had a supersonic aircraft and you're trying to a personal supersonic aircraft today, you really would have to go over the water like the Concorde before you could break the sound barrier. But if you drop down that noise level considerably, then you open up virtually the whole of the United States in terms of being able to fly something as supersonic aircraft, which would be a boon to the industry, because going supersonic is not particularly difficult. It's all the noise that it makes that people don't like, because it rattles homes and breaks windows and scares the animals and all the other things that it does. If you've ever been around a place where they've had a sonic boom, I've done that outside of the United States, it's loud.
Yeah, that was going to be my next question, because I don't have any perspective on this. Like, I'm aware of like kind of what it would sound like, I think, from watching History Channel or something, but I don't like you said, I don't have any experience with those sonic booms.
The place in the United States you probably would hear the sonic booms the most, and this would be several years ago, obviously, was when the space shuttle came back to Earth. There was 2 sonic booms, if I remember correctly, you could hear from the ground. And I remember being in Florida one time when the space shuttle was coming back, and you could hear those sonic booms, and we weren't particularly close to the flight path of the space shuttle. And you just think to yourself, I can't even see. Well, could I see it at the time? I don't think I could see the space shuttle at the time. I remember seeing the space shuttle come in to land at least one time and hearing those sonic booms and thinking, man, that is really, really loud. But that'd be the only time that you, as a civilian in the United States, you probably actually heard of a sonic boom, was when the space shuttle was coming back down to Earth.
Like fighter jet flybys, anything like that? Like they're never going fast enough to do that? No,
they don't do it at air shows. At least they didn't. I've seen the Thunderbirds. I've seen the.
Well, now I'm intrigued. Now I need to make this happen. What can I get? Can I like make some sort of system to shoot my toaster at the speed of sound? And
well, I mean, there's a lot of things to go break the sound barrier, right? The whips will break the sound barrier. Gunshots will break the sound barrier, right? Yeah, they'll break the sound barrier, but they're not the size of an airplane. Yeah. When you have an airplane collapsing the air behind it, it's loud. It's really, really loud. But so the X59 has been that demonstrator, and there's been a lot of discussion in the last 5 or so years about how to reduce the sonic boom noise off an aircraft. The X59 is going to be that demonstrator. One of the interesting pieces of the article is the expense of that aircraft, which is almost $250 million.
Yeah.
For one aircraft. And I always want to put that in perspective, because
we just need economies of scale, Alan. All right, just get one done, then we get a factory. We'll get them down to $1.25 million. Everybody can have one.
Well, was it the B-2 bomber was about $1 billion an airplane, roughly? I think that's a number that sticks in my head. Each one was about $1 billion. And the same thing for the Joint Strike Fighter, where the numbers per aircraft are astonishingly high. And you say to yourself, all right, so how are these EVTOLs going to be really inexpensive? They're not going to be really inexpensive. They're going to be easily, probably $250,000 a pop, right? By the time they're all said and done, and you put your profit margin into them, they're not going to be an every person kind of vehicle, because it costs so much money to make anything out of composites, and the technology and the engineering. Engineers aren't cheap, let's face it.
Yeah.
So there's no cheap airplane today. There just isn't. In fact, Piper just put out a new airplane, which is a trainer airplane. I think it was called the Piper 100. I think it just got certified. And I think the starting list price for that was like $225,000 for the aircraft. And it's a reduced, obviously it's a trainer, so it doesn't have all the bells and whistles. And I think it was only VFR only. So we had a reduced set of like avionics, and it didn't have icing and all that other stuff on it. So even then, even the most stripped down version of an aircraft is still over $200,000, which in the United States is like twice the average cost of a home, maybe 3 times the average cost of a home. Yeah, they're still expensive.
Yeah, well, and what's interesting in this article is they said that they're going to test this over some select communities. So I assume people have to sign waivers, or it'd be interesting to, I'd be interesting to learn what the process is to, who signs up for that or whatever. But they said that this is projected to only either create an inaudible sound barrier, or it'd just be like a very low, gentle kind of like thump. So that's really interesting that obviously, just like we talked about this before on the show, is that okay, this is what we think is going to happen, but then the fact that they are going to actually go fly it over communities to see how people respond. Like I'm sure they're going to have surveys about how did that sound? Is that disturbing to you? That seems to be what's in the plan, which makes sense. Like at the end of the day, you want to see how actual humans react to this plane, not just hypotheticals. This is what this is what we think the decibel level is, and then this is what the actual decibel level is. Then it's going to come down to this is what people think of this. So I thought that was an interesting aspect of it.
Yeah, until they sell. Well, obviously, the restrictions that have been placed on supersonic aircraft are driven by the general public in Congress, because the general public doesn't want to hear it. And if you're living around JFK or LAX or someplace where there's a lot of that kind of traffic coming in and out, you don't want to have big sonic booms going off every hour, every half an hour. And so they put a restriction on it years ago, Concorde-ish, which would be in the 70s. And it maybe had restrictions on before then. So to have a supersonic aircraft break the sound barrier over the United States on a common basis, on a routine basis, would be really new and novel. So the X59 is going to have to do a really good sales job. So part of this is technology driven. Part of this effort is swaying public opinion that this is going to be okay. Probably the public opinion is going to be the harder thing. Technically, I'm pretty sure they can do it. It's going to be the public opinion part in convincing Congress to let loose of some of these laws so that we can fly these aircraft.
So last on our news segment here, some more supersonic stuff. So Virgin Galactic's supersonic rocket plane recently was scheduled to go into the upper atmosphere, but it only got to 40,000 feet before they had an issue, and there was an ignition sequence problem with one of the motors. And so then they had this fail-safe system where, it just sort of shut it down and everyone came back to Earth safely, which is great. But what stuck out at you about this story here with the Virgin Galactic supersonic?
Well, they've been trying so hard ever since they had the accident a couple of years ago to get back into space and to start clicking off some profitability, because I forget how much a flight cost, but it was a couple $100,000 if I remember correctly, to go into space for that limited amount of time and come back. So they need to get going. And this latest flight attempt was really the start of that process to get back into being commercial and to get some of this going. So one of the keys to that whole system, once they had the accident a couple years ago, is to put redundancy into the whole architecture so you couldn't have an accidental actuations, which is what they had in the first one, or making sure that everything about the rocket motor, which is a solid propellant motor, once you light it, it goes. You can't shut it off like you can a lot of other rockets. So there's a lot of safety features that have gone into this newer version of that rocket plane. And it didn't ignite. They had some sort of communication issue between the aircraft and the rocket, and it said, go to safety mode. So there's no other propulsion for that aircraft. It has to glide back, kind of like space shuttle, glide back to the landing spot in the middle of New Mexico desert. And with the COVID restrictions they've been having on their program, they're limited, like who can be on site and who can help on site. And when they try to have a launch, there's a lot of organizational things that they have to do to meet the COVID restrictions. So not only did they not launch it, now they got to recycle and figure out what happened
Yeah.
and get it going again. But the COVID is going to slow them down to getting back in space.
All right, so in our engineering segment today, we're going to talk about the Boeing 787, which is having issues once again. So Boeing back on August 28th said they were having some manufacturing issues where different sections of the fuselage were joined in the aft body section. And they said it just didn't quite meet their design standards. And they found that same issue in another section of the fuselage just recently. So 8 Dreamliners were pulled from service from, I think it was between United, Air Canada, and Singapore Airlines. So, Alan, in reading 2 different articles about this, it wasn't exactly clear to me what the issue was. I heard it described actually 2 different ways in 2 different reportings of this problem. So, what is the issue with the fuselage here?
It looks like it's a shimming issue that when you make any composite parts or even metallic parts, they never come out, especially as large as those parts are. They'll never come out exactly perfect in terms of tolerancing and all the way around the circumference. Like if you're trying to put 2 cylindrical parts together that are the size of the 787 fuselage, you can think about how big diameter those pieces are, and you're trying to align them and lock them in together so that you can create a splice joint. And when you do that, obviously gravity has an effect, and they don't stay round. They kind of go oblong. So you're trying to lock them into place, and then as you create any kind of composite joint, sort of splice joint, you want to make sure that the overlapping parts are tight and that there's only a maximum amount of gap between those 2 pieces, because you're usually sticking some sort of adhesive in that joint, and then you're pushing fasteners through the joint. So fasteners work best mostly in shears. So if you think about it, the fastener goes through the 2 pieces, and there's a nut on the bottom, like a bolted connection on a car. And so what you want to avoid is you have any sort of gap between those 2 pieces, because that puts a lot of stress on that bolt that's sitting in between them. So the bolt's not designed to do that. The bolt's designed to kind of work in shear, not to be twisted and bent and all kinds of other things that can happen if the 2 parts aren't aligned and touching one another like you think that they should be. So if you have a shimming problem where you're not accurately getting the parts lined up and you don't know it, you're going to have problems out in the field. And it takes a lot of concerted effort to make sure on the manufacturing floor that those parts meet the engineering requirements for fit. If they don't fit right, all your engineering work isn't proper. What I mean by that is that the calculations you've done to show the strength of that joint are not right.
Yeah, they don't match up in real life. Yeah,
they don't match up, right? They're going to be less strong. It's just in simplistic terms, they're going to be not as strong as it would be otherwise. So the engineers that are designing the aircraft have a disconnect between what's actually going out the door, and obviously manufacturing is in the middle of this, trying to meet the engineering requirements the whole time. And shimming is sort of an art, not so much a science. It's a little bit of an art. You got to know what you're doing. And it takes a little bit of time to learn that. And I remember doing a lot of composite fuselage connection joints and thinking, man, this is a lot of work. You kind of put it together, take it apart, put it together, take it apart. Feeler gauges, shims, liquid shims, epoxy shims, sort of thing, to make sure those parts are tight. If you don't get them tight and you put it together and have to realize it after it's always assembled, like you just really cost yourself a fortune. So it looks like once Boeing identified they had this shimming alignment problem, that they started looking elsewhere for it, because it's probably not in just one spot of the aircraft. It's probably in different places. It's most likely a training issue. So they're starting to find it in other places. Surprise, surprise. What I think is important here is that Boeing is under a lot of pressure to divulge all that to the FAA and make sure the FAA is up to speed. So now they're being really upfront with the FAA and saying, hey, we have this issue that has now expanded in scope. Here's how we're trying to deal with it so that we don't have an issue in service. And it just, If there's one thing that Boeing can't seem to get out of its own way right now, but that's just the realities of manufacturing anything as technically difficult as the 787 or the new 777 or any of these airplanes. It's difficult to manufacture these things to begin with. So it's not abnormal to have these situations come up, but they get highlighted because Boeing's had the 737 problem.
Well, I remember reading a report and just learning about Boeing as a company. And in the past, they used to manufacture a lot of the plane in-house. Like they had very tight internal controls of not every part, but lots more than they do today. And today, I know lots of different parts are subbed out where, the fuselage might be coming from this country or that country and this part of the United States. And a lot more pieces are coming from a lot of different other vendors. So do you think that contributes to this difficulty where it's just tougher to maintain as strict tolerances when it's not made in your own facility? Or is it just a big problem just in how exacting they have to be?
It's a combination of both. In this particular case, on the 787, the initial program push when the aircraft was being developed was Boeing was going to be an assembler, not a builder of components. Mm-hmm. And that's sort of how it lined up because it de-risks Boeing. So Boeing doesn't have to put all the money out for all the tooling for all the pieces and have all the employees to build all the parts. You sub it out to other contractors, companies that can do that, and you make them quote unquote partners, which means that they, on some level, are contributing financially to the success of the program. So all their sub-suppliers are, in one way or another, supporting Boeing. That's a weird way to think about it, but financially, that's kind of how the transactions go. So if you're Boeing and you have $1 billion program or a $2 billion program coming up, those risks are extremely high. So what do? You start offloading the risk to your suppliers and saying, hey, suppliers, no longer are you just going to sell us parts and make a ton of money and buy Ferraris and new boats. You're going to be part of this process. So if this airplane goes wrong, you go wrong and you can't buy the new boat. And that's how the 787 program kind of started. Now, that didn't turn out the way they thought it was going to turn out. So now when you have it's sort of a mix now. Boeing has taken some of it in-house or ships some of the responsibility to other suppliers to have more concise built parts. But matching two parts together and working between companies to make sure everything lines up just right is still really, really difficult. And hey, Boeing's having a problem with it.
All right, so in our final segment today, we're going to talk a little bit about urban air mobility in general, specifically Blade, which is poised for and entering into the public stock market. So they're going to have looks like an IPO, or they're going to join the NASDAQ pretty soon. They're going to rebrand as Blade Urban Air Mobility. And just as some background, they right now operate in 4 main areas. They have their short distance flight, Blade Airport, which is sort of like New York area airports, to different lounges in Manhattan. Blade Metamobility, which is the transportation of human organs and other medical services. And then they have some international ventures. So, Alan, this is a company that's expressed interest in joining this fight into, if you want to call it a fight, into the EVTOL market. Not as building planes, like that's not their goal, but just in the infrastructure and airports and some of the things that companies we've talked about before that, the aircraft manufacturers themselves probably shouldn't be doing. So in reading up about Blade, what do you see as their role in this whole big scheme of urban air mobility?
So the way that a lot of these essentially are fractional ownership programs, it's essentially what it is that you pay a lump sum per year to have access to a certain set of aircraft, and then you pay per flight based on a sort of prearranged scale of what airplane is and where it's going and all these other factors. So Blade is in that marketplace, generically speaking. I don't want to get specific about them, but just generically speaking, that's what's happening. And so they are really dealing with the end user, the customer, the person needs to travel from New York to Miami or out to the Hamptons. They're dealing with that particular customer. And that's a different skill set than designing an airplane and building an airplane. Usually those two skill sets don't really align so much, and that's why the aircraft companies have a hard time running fractional ownership programs versus companies that are specifically designed to deal with that particular clientele. It's like selling cars to like Ferraris, and it's a different clientele than selling Chevys. It's just a different marketplace. Mm-hmm. So there is value in it. The aircraft companies have an odd relationship with that. Those kind of like Blade, and I'm going to use NetJets, and there's a couple others. They want to buy airplanes in quantity at discounted prices. So as an aircraft manufacturer, you think, okay, great. I mean, so I can keep my production humming at this certain level because they're going to buy these airplanes. And then if I sell an aircraft to a famous actor or actress or somebody, I'm going to charge them full rate, right? So I can pay for all my overhead to operate the factory and make airplanes by selling to these fractional ownership company. And then my super profit margins happens on these individuals I sell airplanes to. So it does provide some stability to the aircraft companies, but at the same time, the aircraft companies realize what's happening on the other side. They see the profitability that's happening on the other side when they're charging $10,000 a flight and all this other stuff. So there's a little yin and yang in this. Both of these pieces have to work together and survive. Otherwise, no one wins. But the airframers don't really like it all that much because they see the profit they're missing out on. And the companies that are operating the aircraft don't like to be gouged on aircraft prices either. So it's a funky marketplace. And you have to really balance out on the aircraft side what you're willing to do. Because you think, I'll give you a good example. So you think someone like Cessna or Textron could really operate a fractional ownership program because they're making the airplanes. If they could sell airplanes to themselves, they sell them at cost, essentially, and you'd have the best market. But it's just such a different place to advertise into, to network into, to sell into, and the customer demands can get funky. And big corporations don't do very well in that marketplace, or haven't. And so a couple of things like Blade, and in which there's going to be more and more of them as EVTOLs start to pop up, are going to be out there selling their product directly to the marketplace and creating that marketplace. And the aircraft companies are just going to have to sit there and swallow it and take it and know that it is helping sell aircraft. It just different markets, that's all.
Yeah, well, and Blade, they have it seems like they have a lot of different ways you can book primarily helicopters right now from their site. And so I went on and I tried to book one. So I just chose a route, it was from the one I chose from JFK to a Manhattan helipad, and it was $1,775, which could be you and up to 5 other people. So it's up to 6 people. So, $300 for a short flight across, New York. Not the state, obviously, just the city. And, but one of the big battles that they've been talking about with transportation is just cars, and the cost of, operating your own car per mile is, 30 cents, 38 cents a mile, something like that. So very cheap compared to taking an Uber, which is maybe $2 a mile, something like that. And then you talk about helicopters and then EVTOLs, which will be a lot cheaper than these helicopters. But so it's just like that battle to get costs down and say, like, can people really afford this as a commuter? Is this going to be $1,000 commute? Taking a EVTOL from, here to there. Could you do that? Could this be financially viable to do it 5 days a week? Or is it just going to be really, really hard to outrun just the regular household, Honda Accord, for your daily commute?
Dan, think of it this way. If you had to leverage, let's just say you had 10 EVTLs of $200,000 each. So you got $2 million leveraged, right? And you're trying to pay that off one flight at a time. That's really difficult to do. And all it takes is a slight downturn in the economic conditions where all of a sudden you can't make payments. And that's what historically has happened with these companies, is that they can't make the payments during the downturns. And then they're doing great when the economy is roaring along, but as soon as something happens, they can't pay. And then they fold, and then the airplanes are, auctioned off or reacquired or something. So it's, in theory, it makes total sense. The problem is it's totally, it is mostly dependent, not totally dependent, but mostly dependent on just living on the upside. It's like living back in the 1980s in the Reagan administration when things are just going boom everywhere. Well, at some point they kind of slow down, you know, and that's, you got to get your money in the good time and roll out the bad times. The problem is the good times aren't long enough right now to do it.
All right, well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.